So this is the second example from this topic, and we're going to go through and talk about finding some equivalent angles. And I've also given you a value for sine theta, which is the reason why the first 4 questions are standard questions, questions that you should be able to do by the end of today's lesson. But the last 3 questions are a bit trickier because they make a slight change, and I'm going to show you a couple of things which are a little bit beyond what you need to be able to do now, but I can just start seeding that in. Okay. We're told sine theta in the first quadrant. You might get some questions where you're just asked to find what sine of, say, pi plus theta is in terms of a first quadrant angle, which means you're trying to get it back to an angle that doesn't have that pi relationship in there. So I'm going to just pick particular colours. So I'll do the first one in green, but the first thing I'm going to do is draw that first angle. So here's sine theta, there's theta, and we know that sine theta is 4/5. So that means that the height is 4/5, which also means that this coordinate is p bracket something. I don't know what that something is, but the y value is 4/5. So that's going to be important for me to define these relationships. So first of all, A, the green one, sine of pi plus theta. Well, pi is this angle around here. Remember, I'm using radians as much as I can now, but if you're not sure, pi is 180 degrees. So it's halfway around the circle. And pi plus theta is this angle down here. And it fits in my rectangle. That's theta, and here is pi plus theta. Now, sine of pi plus theta is therefore this height. So that's sine of pi plus theta. And hopefully you can see that sine of pi plus theta will be equal to sine of theta, except it's negative because it's below. And that actually fits my cast diagram, which I'll just quickly draw on here. C-A-S-T. Sine is positive in the first quadrant, but negative in the third. So I'm going to write that answer down now. This is equal to negative 4/5 because it's negative down here. That's the first one. Second one, which I'll do in orange, sine of theta plus 2 pi. This one's actually probably a bit easier than the first one, because if I get theta plus 2 pi, which is the same as 2 pi plus theta, here's my 2 pi here, and if I add 2 pi to that, theta to that, I end up here. This is theta plus 2 pi, which is actually just the same as theta. And that's something else we talked about last lesson. If you add 360 degrees, you do a full rotation, and you end up back where you started. And 2 pi is 360 degrees. So we've basically just done a full rotation. So sine of theta plus 2 pi is actually equal to just sine of theta, which equals 4/5. So just remember that. If you do a full cycle, a 2 pi or a 360, or multiple full cycles, so 720 or 1080 or 4 pi or 6 pi, or you take away cycles, that you end up back where you started anyway. So just keep that in mind. The next one, sine of pi minus theta, which I'll do in purple. Pi minus theta, well there's pi. So pi minus theta is in the second quadrant here. That angle is theta. You see my rectangle is important now. This is just a geometry principle. This angle will be the same for each diagonal. That angle is theta, and sine of pi minus theta is this height, because sine represents the vertical component, and this point here is my pi minus theta point, and sine is positive in the second quadrant, and you can see that that height is above the x-axis, so sine of pi minus theta is equal to 4/5. And then the last one is sine of 27 minus theta. Now again, there's a few different ways we can approach this type of question, but ultimately 27 pi is a number of rotations. We've gone around that circle quite a few times. So I need to take out all of those rotations if I can. The way I would approach some of these questions, and the textbook does it slightly different, so you can pick your way. As long as you justify it, I don't really mind which way you do it. The way I would approach it is I'm going to find all of those rotations. I'm going to recognise that because I'm rotating, every time I rotate it's 2 pi, I'm going to take out the biggest even number of pi that I possibly can. So 27, I know that's got 26 pi in it, plus another pi and minus theta still. And that 26 pi rotation is 13 times around the circle. What's that for you? Sorry, this way around the circle for you guys. So 13 times I've gone around the circle, and those 13 times get me back to where I started. So I'm actually just going to remove the 26 pi. This is now equal to sine of pi minus theta, which is equal to 4/5, because this is question C. So actually, think about this for a second. How many questions can this exercise ask you? If you're given sine theta in the first quadrant, there are only 3 questions, and then variations on those 3 questions where you do extra rotations or you subtract rotations. There's not actually that many questions. You just need to understand the mappings. So that's pretty much what you need for the next exercise. I'm going to go through E, F, G now and talk about them briefly and answer any questions. But really, if you can do that, you're pretty good for that next exercise. And that's the basic skill that you need to be able to do things like solving trig equations and using trig models later on, and in the PSMT next term. Chris, did you have a question? Good? Okay. Any questions before I go on EFG, and then I'll leave you be for a little while? Okay. So let's quickly talk about E, F, and G. These I'm going to draw extra new diagrams for these and show you what I would expect a unit circle to look like. And they are extensions. So if you understand them now, great. If you don't quite understand them now, that's all right, because I'll show you them again. And I just this is a good opportunity for me to show you a little bit beyond. So first of all, cos theta. Now I know sine theta is 4/5, and I want to find cos theta. So there's a couple of ways we can do this. One way you haven't seen yet, but I'll show you that in the unit circle later. I might show you now. But another way you can definitely do. And you'll notice here, because we know sine theta, so E, we know that sine theta is equal to 4/5. Some of you might take this question and just do the old shift sine 4/5. There's my theta, cos of that answer, and you'll get an answer. And if you do that and you're not careful, you might get an answer that's not perfectly correct. You'll have some rounding issues. And so it's not the perfect way to do it. And in fact, we're discouraging you from doing that because it's quicker and we want you to know the relationships. So there's going to be some trivial questions you could do with your calculator that we want you to avoid for now. This question could come up in a non-calculator paper. So imagine I've got the unit circle, but I remove the circle. So now it'd be like, going to McDonald's and asking for a cheeseburger without cheese sort of thing. I'm left with this, P something, comma 4/5. And I know that this is my sine theta, so I know that this is equal to 4/5. And it's a unit circle, so I know this is 1. Okay? Now what I want to find is cos theta, which means I want this thing here. I want the missing coefficient, because I know cos theta is my horizontal bit. Can anybody tell me something that you learnt in year 8, year 9 that could help us find cos theta? And the big name for that is? Pythagoras Theorem. So we could use Pythagoras Theorem here. And I'm going to show you this Pythagoras Theorem solution, and then I'm going to quickly show you the generalization, which we don't need quite yet, but you'll see it there. So Pythagoras Theorem would give us 1 squared is equal to 4/5 squared plus cos theta squared. And that means that 1 squared, which is just 1, minus 4/5 squared. When you square a fraction, you just square the top and you square the bottom. So you get 16 over 25 is equal to cos squared theta. I chose these numbers originally for a very specific reason. You'll see certain numbers come up in your exercise more often than others. That becomes 9 over 25 is equal to cos theta squared. And when I square root 9 over 25, I get 3 over 5 equals cos theta. Now, some of you, and rightly you would say, hold on, you took a square root. What happens when you take a square root? What other thing you've got to consider? Sorry? So it could be negative. So you've got to consider the fact that when you take a square root, it could be plus or minus. But we do know, because cos theta is sometimes negative when sine theta is positive, isn't it? We know in this case that sine theta is in the first quadrant. We're told theta is 0 to 90, and therefore cos theta is in the first quadrant, and therefore it's positive. So we know it's positive. I'm going to write down here, question indicates theta in first quadrant, and therefore cos theta equals positive 3/5. So that's guaranteed. You're going to have to start thinking about which quadrant your solution's in as to whether cos theta or sine theta are positive, negative based on that. So just make sure that you take the time to consider that. It does lead to this generalisation over here. If I just do Pythagoras Theorem on the standard triangle with no numbers involved, I get this. Cos theta squared plus sine theta squared equals 1 squared. Here's the actual generalisation. It looks like this, and there's something new here. Feel free to ask me a question once I've done it. Cos squared theta plus sine squared theta equals 1. Can you see something that they weren't expecting here? They want to ask about? Sorry, that say that again?
You didn't square.
I didn't square?
Didn't square it.
Well, I've squared. What do you mean? I squared that. Be more specific.
I don't know how to explain it.
Chris, you got something?
You can't square an angle.
Square, sorry?
Can you square an angle or no?
Well, that's a good question. So it's the move I've made here, isn't it? I've gone from sine theta, brackets, squared, and I've put the squared inside here. Okay, so this is actually a mathematical convention. If we're squaring cos theta, the squared goes here. Can anybody think why that might be the case?
So it doesn't confuse if you're squaring the angle or...
That's pretty much it. And you know what? I can't even think of an example where you'd want to square an angle. But if you write this, cos theta squared, just like that, this means cos of the angle squared. So you've got to, this is an order of operation thing now. If you write cos theta squared, you will square the angle because in our order of operations, we do the indices first. We square the angles and then we apply cos of that. Whereas up here you can see we wanted to do sine of this angle and then square it. This is the notation for that. So you'll see this a lot now. It doesn't mean that. It means this. So you just got to be careful with that. But there it is. This is the... sorry about the colour, but I'll just move along here and write this down and then we'll move on. This is called the Pythagorean Identity. And it's quite important and you'll see it a lot. If you're in specialist maths, you'll see it a lot. And it comes straight from that unit circle, easy as you like. It's an obvious identity. It's not an equation. It's called an identity because it is true for any angle. I guarantee you pick an angle between negative infinity and infinity and do sine of that angle plus square it and then do cos of that angle, square it, add them together, you get 1 every single time. So it's called an identity because it's always true. So there we go. There's the answer to that one. E is quite logical but a little bit beyond what you need for right now. And F follows from E. So now question F, which you couldn't have done before. So I've just scaffolded the question. 3 pi plus theta, I know this. I know that cos of theta, where theta is in the first quadrant, is equal to 3/5. I draw my unit circle. I pick a random point. I don't really care what theta looks like. I'm just picking a point there. I'm calling that theta. I throw the other diagonal on. See how these are the diagonals of my rectangle without there being a rectangle. And I throw a theta here because I know, and you might not see this yet, but I know that's going to end up in the third quadrant. Cos of 3 pi plus theta is equal to cos of 2 pi plus theta. I can remove the one full rotation. It's equal to cos of pi plus theta. And pi plus theta is here. That's my pi plus theta. I add my cast diagram information, CAST. Cos of pi plus theta is in the third quadrant. Tan is positive, but cos is negative. And therefore, cos of pi plus theta is equal to negative cos of theta. And therefore, it's equal to negative 3/5. Now, with some of these easy questions, it's going to be quite easy for you just to write down the answer. But that's not going to show any justification. So having these steps here and a unit circle is your full justification. This is expected. Make sure that you're showing that. And question G, again, is a little bit beyond, a little bit different. Sine of pi over 2 minus theta. I'll run through this quickly because it is a little bit different, and then I'll leave you be. So this is G, sine of pi over 2 minus theta. So sine of pi over 2 minus theta exists in a different area of our unit circle. So my unit circle, which are getting progressively worse drawn. Wow. I'm leaving it. Because you know what? The unit circles, you're not going to get marked on a neat unit circle. As long as it's reasonable, I'm going to leave it there. Okay, let's imagine we had this triangle here, and that's theta. This angle up here is pi on 2, so hopefully you can see that pi on 2 minus theta is actually here. Pi on 2 minus theta is there. And so this is my pi on 2 minus theta. So if I'm trying to find sine of pi on 2 minus theta, have a look inside that triangle. You might have to apply the same logic we did before. Inside that triangle, I've got a length of 1, and sine of pi on 2 minus theta, so this angle there is pi on 2 minus theta. So I want to find this height. So sorry about all the colours, but there's my diagram. This is theta. I've just transposed that up to there so I can relate the angle to pi on 2. And I've marked this point here, which is pi on 2 minus theta. So that means sine of pi on 2 minus theta. This is pi on 2 minus theta, by the way. Sine of pi on 2 minus theta is this height. That's what I want. Backshot.
Just be the cos value that you figured out originally.
That's pretty much where we're heading, yeah. So sine of pi on 2 minus theta is this height, which hopefully you can see the height of this triangle is actually the base of this blue triangle. So we're now reading off what is called reading off the vertical axes. The height of the triangle in purple is the base of the triangle I created in blue, and if you have a look at that base, we get this rule. Cos theta is equal to adjacent over hypotenuse, which is equal to, I'll just call it height for lack of a better thing, h over 1, so it's equal to h. The height is equal to cos theta, and the height is equal to sine of pi on 2 minus theta. So we actually get through just a nice simple diagram now like that where you had to be a little bit intuitive to transpose that triangle to there, but otherwise the rest of it follows just through simple trig. Nice little diagram like that. You get the relationship that, I'll zoom out a little bit for this, sine of pi on 2 minus theta is equal to cos theta. And so in this case, what's cos theta? 3 over 5. 3 over 5. And this is another identity, which we'll get to a little bit later. So this is beyond what you need for any exercises this term. But I'm just showing it to you now. Then when I show it to you again, some of you already have a bit of an understanding about it. This becomes another identity. Sine of 90 minus theta always equals cos of theta for any theta. Try it. And theta doesn't even have to be between 0 and 90. Theta can be 1 million degrees, and it still works every time. And the reverse works as well. Cos of 90 minus theta equals sine theta for the same reasons. But we'll get there. Hopefully some of you, if you've got a tricky question like that, might be able to play with those diagrams and determine that relationship and then answer the question. But otherwise, today, A, B, C, D, it's in exercise something. I might just stop this now.